Okay. So, I have covered that properties of DFT in this week and the linear filtering, that overlap add and overlap save method. So, based on that I will just solve few problem, so that you can understand whatever the theory I have covered during the last 4 lectures. So, let us, the first problem is defined: compute n point DFT of x of n. Let us say very simple first, DFT. Compute n point DFT of x of n 3 of delta n. So, very simple. So, you know. Okay. So, I know that what is, let us say x n point DFT of x of n is equal to DFT and n point is x of k. So, what do you know? X of k is equal to n equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n into n k. So, I can simply say n equal to 0 to n minus 1 3 into delta n into e to the power minus j 2 pi by n into n k. Now, you know the delta n is equal to 1 when n equal to 0, elsewhere else it is 0. So, I know this is only exist when n equal to 0. So, 3 into delta 0 into e to the power 0. So, I can say it is nothing but a 3 into 1 is equal to 3. Now, instead of delta n, if I say 3 delta n minus 2 delta n minus 2, 3 delta n minus 2 delta. So, my x of n is equal to 3 delta n minus 2 delta n minus 2. So, what I can say? I can say my signal x of n is nothing but a 3 0 minus 2, where the 0th point is 3. So, what do you know? You know x of n minus L. What is the, if I take the DFT, n point DFT, what is the DFT? X of k into e to the power minus j 2 pi by n into n L into k. So, if I say it is n minus 2, that means delta x of n, delta is 1 at 2. So, it is nothing but this is equal to 1 at e to the power minus 2 j 2 pi by n into 2 by 2 into k. So, from the property I can directly calculate, or I can calculate, take the signal and calculate the DFT. Okay. Let us say another, compute the n point DFT of x of n is equal to 7 into n minus n 0. N minus n 0. So, there will be x of n minus n, 7 into x of n minus n 0. Very simple. You can calculate n minus n 0 is the shift, x of n is x of k, and n 0 is the shift e to the power minus j 2 pi by n into n 0 k, and 7 will be multiplied, scalar multiplication. Okay. Let us say other, determine the circular convolution of the sequence. Let us say first I do two things. I said let x of n is equal to, let us say I said 2 delta n minus 3 delta n minus 1 plus delta n minus 3, x of x1 n, and x2 n is equal to, let us say u n minus u n minus 4. Now, from there First I determine the signal. What is x1n? x1 is nothing but a 2 minus 3 0 1. Here is the 0th point. And what is x2n? So, let us say x20 is equal to u0 minus u0 minus 4. So, what is that? u0 minus u minus 4. So, minus 3, which is nothing but a 0, or I can say the x2n is only there. So, if we see un means all are there, and un minus 4 means 0, 1, 2, 3, 4. At 4 there will be a 1. So, this is subtracted. So, this part becomes 0. So, I can say x2n is nothing but a 1, 1, 1, 1. Okay. So, I can do that. Now, what I said, calculate the circular convolution of the sequence. So, how do you calculate? So, I know x1n. So, I write down the top, x1n is equal to 3. Now, what is 2 minus 3? 2 minus 3, 0, 1, and this is 0th sample, and x2n is equal to 1, 1, 1, 1, and this is 0th sample. Now, I said calculate the circular convolution of n is equal to 4. N is equal to 4. So, 4 point circular convolution I have to calculate. So, what I can say? How do I represent circularly x1n? So, I draw that. See that you do not know anything, you just draw the circle. So, now I get 4 index. This is index 0. So, inside you write down the index. Index 0 is this one. So, if I go anti-clockwise, it is a positive index. So, 0, 1, 2, 3. So, I know 0 sample value is 2, 1 sample value is minus 3, 0 is the second sample value, and 1 is in here. So, this is nothing but a x1n. Similarly, if I want to draw x2n, so this is 0, 1, this is 0, 1, this is 0, 1, 1. Let us do that circular convolution, because 1, 1, 1 you cannot understand the shift. Let us I say I want to calculate x3m, which is nothing but a x2n and x1, you know, m minus n, circular convolution of n. You know what is? Told me n equal to 0 to n minus 1. That is my circular. So, I am saying instead of x2 I said x1 I want to circularly convert. So, I have to calculate x30 is equal to n equal to 0 to 4 minus 1 x2n multiplied by x1 minus n. So, x1 minus n. So, if I want to draw the x1 minus n, so this is x1n, x1 minus n. So, minus n means flip the signal. So, if it is 0 index, this is positive index. So, this is negative index. So, 0, 1, 2, 3. So, 0 value is 2, 1 value is minus 3, 2 value is 0, and 3 value is 1. So, x of n 2 minus 3 0 1, x1 minus n 2 1 0 minus 3, this side. Now, I know x30 is nothing but a sum of the product of x2n. So, x2n is 1. So, 1 multiplied by 2, 2 plus 1 multiplied by 1, 1 plus 0 multiplied by 1 0 plus minus 3 multiplied by 1 minus 3. So, it is nothing but a 2 plus 1 minus 3 is equal to 0. Similarly, when I say instead of this one, if I say what is x3 1, it is nothing but a sum of n equal to 0 to 3 x2n multiplied by x1 1 minus n. So, if I say this is my x1, this is 0 2 1 0 minus 3, 2 1 0 minus 3 is my x1 minus n. I can say that x1 1 minus n should be the one positive shift. So, I have to shifted this circle in 1. So, 2 becomes, so I can say 2 goes to 1, 1 becomes here, 0 becomes 1, minus 3 becomes here. Now, this has to be multiplied with x2n. So, I know x2n is nothing but a all 1. So, I can say minus 3 1 minus 3 plus 2 1 2 plus 1 1 1 plus 0 1 0. So, it is also 0. So, I can calculate. So, instead of this kind of example, let us take another example. Let us say I have an x1n, calculate the 4-point circular convolution of x1n. x1n is equal to, let us say 1 2 3 4, and x2n is equal to let us say 1 minus 2 0. And I have to calculate 4 point n is equal to 4, well not 0, let us say this is minus 2 2, let us say. So, this is length is 3, so I have to pad 1 0, 1 minus 2 2 0. So, now I have to draw, first you draw x1n. So, when you draw, think that this is your 0th sample and this is your 0th sample. So, anti-clockwise index is positive. So, if this index is 0, then this value is 1, and this index is 1, value is 2, this index is 2, value is 3, this index is 3, value is 4. So, this one is my x1n. How do I represent in x2n? This index is 0th index 1, 1 index minus 2, second index 2, and third index 0. So, this is my x2n. So, I know the circular convolution x3m is equal to n equal to 0 to n minus 1, x1n convolved with x2m minus n circularly. So, if I say what is the value of x3 0? So, I want to calculate x3 0. I know n equal to 0 to 3 x1 n or xn minus 1 into x2 minus n. So, if this is x2n, then what is x2 minus n? x2 minus n. So, x2 minus n means folding, negative index. So, this index is 0, 0 is 1, minus 1 is minus 2, minus 2 is 2, and minus 3 is 0. So, this is x2 minus n. Now, I said x3 0 is nothing but a summation of n equal to 0 to 3 x1 n into x2 minus n. So, if it is 3, so this is nothing but a product. So, one product will this. So, what should be the product circle? This multiply with this 1, this multiply with this 0, this multiply with this 6, this minus 2 multiply with this minus 8. So, what is the sum? Sum is nothing but a 1 plus 6 plus 8 minus 8. So, which is nothing but a 7 minus 8 is equal to minus 1. Now, when I say x2, when I say x3, 1, that means this will be 1 minus n. So, 1 minus n means x of minus n has to be shifted this side one sample. So, if I want to shift, that means this is what? This value is 1. This value is 1. So, 1 will be goes to here and 0 will be come to here, 2 will be here and minus 2 will be here. Then the product will be minus 2 into 1. So, the product circle will be minus 2, 1 into 2, 2, 0 into 3, 0, 2 into 4, 8. So, the sum of 2 minus 2 and 8. So, it is nothing but a 8. So, that way you can calculate the circular convolution for any sequence. Okay. I can calculate the 8-point sequence also. If it is 8-point sequence, so you have to think this is my circle. So, I get 4 points. So, this is 1, 2, 3, 4, 5, 6, 7, 8. So, this is the zeroth index, 1 index, 2 index, index 3, index 4, index 5, index 6 and index 7. So, I can represent an 8 things. Now, again you shift, same convolution is same. Okay? So, that is circular convolution. Next problem, let us say if x of n is real 5-point sequence and 5-point DFT of xk is given, determine the value, energy value of the signal. So, I said what is the energy of the signal. So, what is given? x0 is equal to 4, x of 1 is equal to 1 minus 2j, x of 3 is equal to 3 plus j. Then what you know? 5-point DFT, x of n minus k is equal to x star k. So, x of n minus k is the complex conjugate of xk. So, if I say x of 4 can be represented as x of 5 minus 1, which is nothing but a complex conjugate of 1. So, if it is 1 plus 2j, then what is the complex conjugate? 1 minus 2j, so 1 plus 2j. Now, what is the complex conjugate? x5. x5 is x of 5 minus 0. Again 4. So, I do not require x5. So, I have a 3-point is given. So, what is not given? x2 is not given. What is x2? x of 5 minus 3, which is nothing but a complex conjugate of x3, which is nothing but a 3 minus j. Now, what is energy? Energy is nothing but a x0 square plus x1 square plus x2 square plus 2 plus x3 square. Plus x4 square. 5-point DFT. So, 1, 2, 3, 4, 5 components are there. So, this since DFT is magnifying by 1 n, so I have to divide it by n. N is nothing but a 5. So, if I say energy of the signal x of n is nothing but a energy E is equal to summation of n equal to 0 to n minus 1 x of n whole square is equal to 1 by n x of 0 square plus x of 1 square plus x of 2 square, sorry, third bracket or first bracket, third, I generally write third bracket, plus x of 3 square plus x of 4 square, 5 point DFT. Okay. So, n is equal to 5. So, 1 by 5 into x of 0 square. What is x of 0? Is 4, square means 16, plus x of 1, 1 minus 2j. So, what is the mod of x of 1 minus 1? What is the mod? So, this all will be mod, sorry, all will be mod, power. So, mod square, mod x2 square, mod x3 square, mod x4 square. So, what is the power here? x1, 1, power is nothing but a root over of real square plus imaginary square. So, it is root of 5. So, square of root of 5 means 5, plus x2, x2 is 3 minus j, root of 9 plus 1, 10, root over of 10 square means 10, plus x3, x3 is 3 plus j, again 10, plus x4, x4 is 1 plus 2j. So, it is nothing but a 5, 1, 2, 3, 4, 5. So, I can say 5 plus 5. So, I can say 5 plus 5, 10. So, 10, 10, 20, 30, 30, 46 by 5. Okay. So, that is the energy of the signal. Similarly, let us say this one. A speech signal is sampled at 8 kilohertz. A DFT is computed of a block of 1024 sample of the data. What is the duration of the block? So, I have a speech signal sampled at 8 kilohertz. That means, I can get 8K sample in 1 second. Okay. So, what is my length of the DFT? N is equal to 1024 point DFT I have calculated. So, I have calculated a sample block which is 1024 sample is there. So, L is equal to 1024. I know what is the duration. So, 8K sample at 1 second. So, this number of sample how many seconds? So, I can say 1 by 8 into 10 to the power 3 into 1024 second. That is the duration. If I convert it into millisecond, so 1 by 8 into 10 to the power 3 into 1024 into 10 to the power 3 millisecond. This is cancelled. So, 1024 by 8 millisecond ms. So, 1024 means you can check it 1, 2, 2, 4, 5, 4, 5, 125.5 millisecond, the duration of the block. What is the frequency resolution of the DFT? What is the frequency resolution of the DFT? So, what is the frequency resolution? You know, 2 pi by n. 2 pi is equal to Fs. Fs is 8 kilohertz. 8 into 10 to the power 3 divided by n is 1024. Approximately, I can say 1000. So, it is approximately 8 hertz. Now, if only 512 sample were taken, but the block was zeros added to do 1024 point DFT, then what would be the new answer of B? What is the resolution of the? Have you understand? I said instead of taking L is equal to 1024, I take L equal to 512 point. 512 data point I have take, and I padded up another 512 0 to make it 1024 point DFT. So, the resolution does never change. Resolution depends on the length of the DFT. Now, if my length of the DFT is reduced to 512, then what should the new resolution? New resolution will be again Fs by 512, which is nothing but a 16 Hz. So, you know that resolution is inversely proportional to 1 by n. So, if we increase the length of the DFT, your frequency resolution is increases. But what is happening, if you see, suppose I have a long signal. So, let us say it is a non-stationary signal, let us say speech signal. So, sometimes silence, then there is a signal, then silence. So, along the timeline, signal is non-stationary. So, if I take entire signal at a time and let us say this is my x of n and do my xk. So, I get a frequency response which is, I am considering that entire time duration signal is stationary. You know that this is the Fourier basis. I am saying entire time duration signal is stationary. That means non-stationary signal, stationary signal. Stationary means the frequency composition of the signal does not change along the timeline. So, time invariant signal, but actual signal is time variant. So, if I take the frequency transform, I get an average frequency response of all the signals. So, it includes the silence response, it includes this portion. So, now I said no, since it is a non-stationary signal, if I make a small window, then small window I can say stationary. So, I am analyzing window by window of length L. Then I said I have taken a x of n of length L and I calculated x of k. Now, once I take n point DFT, so the frequency resolution is 2 pi by n. Now, if I increase n, I have to take more number of samples. So, if I increase frequency resolution, time resolution is decreased. I am not getting that how the signal is changed along the timeline. Time resolution increase means small portion of the signal and length of the DFT is less. Time resolution decrease means large portion of the signal I can take. So, if I increase the time resolution, frequency resolution n will be less, decreases. If I increase the frequency resolution, time resolution will be decreases. Now, you may say, no sir, I will take x of n very low L by I padded up with zeros and I make n is very large. Then one point is the computational complexity is increases. Second point is very important point, the amplitude of the frequency response will be get an average flat. I cannot add so many zero. So, when I discuss about the DCT, I will discuss about this. So, this is the lacuna of the DFT. Okay. So, that is that kind of things. So, use this in a practical scenario. I may ask you that suppose I have a signal, I want to, sampling frequency is given, I want to compute the DFT length of this, what should be the frequency resolution? What should be the time, the amount of signal I have to taken? What if that my filter response is this, frequency response this, what is the length of the, you can say that convolution? What is the minimum length of the DFT I should take? Suppose I said I have a signal x of n whose length is L, length is equal to 350 and I have a filter whose order is equal to let us say 100. What should be the minimum length of the DFT? So, you know the n should be greater than equal to L plus m minus 1, which is nothing but a 350 plus 100 minus 1. So, I can say it is nothing but a 450 minus 1, it is 449. How many 0 has to be added with the signal? M minus 1, 99 0. How many 0 will be added to the filter? L minus 1. So, if the signal is sampled at 16 kilohertz, what should be the frequency resolution? You know the frequency resolution is nothing but fs by n. N is equal to 490, 449. So, that is nothing but the frequency resolution of my things. Okay. So, that kind of answer you can give. Okay. So, this we discuss about the one dimensional discrete Fourier transform x of n. Now, think about I have an image. So, let us I take one other slide. So, next week I will start with two dimensional DFT and then go for STFT. So, what I say, if I have a x of n, I take the DFT x of k. So, only n index is varies. So, my signal is one dimensional, x n is varies in this side. Now, suppose I have an image. Now, if can I do the DFT, discrete Fourier transform? So, what is an image? What is an image signal? Is nothing but a pixel. So, if the pixel is represented by I, so I is a function of x and y. If this direction is my x and this direction is my y, so it is started from here. This is x and this is y. So, I is a function of x and y. So, now like that x of n, the amplitude is function of the n. I take that instant amplitude. Here also I digitize the image, I get the pixel index. So, that is called spatial signal. Spatial signal. So, my signal, if my signal is x, or I can say the signal is image is I, is a function of x and y. Or I can say I has a digital index both m and n. Instead of x of n, I have a I or signal or x which has a m and n both index. M0, N0, first pixel, 0, pixel, 0, 1, 0, 2, 0, 3, 0, 4, then 1, 0, 1, like that way. So, those are the matrix representation. I have to do the DFT of this. So, I have a 2 dimension. So, 2 dimension I have to do DFT. So, I can take one dimension and another time I can take DFT of one dimension and go to the another dimension. So, I have to take m and n number of, let us say this is you can say m and n number of DFT. So, when I say the m and n number of DFT, so you know the sum sign will be 2. One is n equal to varies from 0 to let us say m minus 1 and n equal to 0 to n minus 1, and then your signal x of m of n into e to the power j 2 pi by n into. So, when I say the DFT, which is nothing but x instead of k, there will be two index u and v. So, I can say u with m plus v with n divided by n. So, details I will discuss in the next week, that what is the 2 dimensional DFT, 2 dimensional discrete Fourier transform. Then I discuss about STFT, short time Fourier transform. What is STFT synthesis and STFT analysis? This is applicable to speech processing and this is applicable to image processing. And next I will discuss about the DCT, discrete cosine transform. So, next week I will talk about the speech processing, image processing, discrete cosine transform related to the DFT, what is the difference between the DFT and DCT, those I will discuss in the next week. Okay? Okay, thank you.